Awesome, guys. We're going to do this a little differently today. I know last time it was kind of hard to get all the blanks, so I'm going to give you time before I talk between each slide to write down your notes. So that's why I'm going to be talking between. So you guys get the notes and then we will talk about it. We all ready? Alrighty. Before I even go to the next slide, what should this tell you about ATP here? When you think ATP, what should you think? Energy. Alright, Stan, when I say ATP, what do I want you to think? You're Stanton, Braxton. When I say ATP, what should you think? Energy. Malachi, when I say ATP, what should you think? Energy. Alright. Again, hopefully this should look familiar. Do you see any similarities between this here and we have an ATP molecule over here? I want you to think macromolecules. Do you see any similarities here? Alright, yeah. What macromolecule would this be? You can nucleic acid. Nucleic acid. So, your ATP is going to be nucleic acids. Alright, anything underlined is going to be your notes, so I will write that down. Alright, are we all good on that, guys? If you have trouble seeing the bottom one, adenosine is what that says. ADENOSINE. Alright, we all in the blanks. So ATP stands for adenosine triphosphate. You get the A from adenosine triphosphate, TP, triphosphate. It's going to be composed of carbon, hydrogen, oxygen, nitrogen, and phosphorus. And that forms that adenosine in the phosphate tail, right? All you need to know that adenosine is adenine, which is a nitrogenous base, and then you have a ribose sugar right there. We can also put it on the board here, which we'll do. Take adenine right here, right? Add ribose sugar, slap in a little bond, right? Take a bond here, add a little phosphate. Keep going, keep going. Oops. Daisy. ATP, voila. Alright, next slide. Let you guys get that. There's only one blank there. Alright, that blank will be chemical. Alright, ATP is chemical energy produced by the cell. We see this produced in photosynthesis, which is going to be used later in the process, and then we have cell respiration. And all cell respiration is a reaction that occurs in the mitochondria. Again, we'll learn this later, but yeah. So I'll let you get this one then. Alrighty, ATP is used when the cell does work. So work is just a very broad term. You can think digestion, after transport, protein synthesis, movement, cell division, DNA replication. The list goes on. You can list 1,000 things ATP is used for. Go to this to name a few. So how do we break down ATP? Let you guys get the blanks there. ATP, all the energy in the ATP, remember we said ATP is the energy molecule, it's going to be stored in the phosphate groups, those bonds right here, but mostly you're going to see in that bond right there, right? When we break a bond, when we break one of the phosphates off, we're going to break the third one because it's the most important, you get energy, right? And then, get rid of that no longer a part of ATP. It becomes ADP, adenosine diphosphate. Remember, di means two. Good on that. All right. So, I'll let you guys get your blanks there on the next page. We have that ATP. You can kind of think of ATP, ADP like a battery, right? ATP is full of energy. Let me just bring that bond back, right? Full of energy, ready to go. Break off that bond, you get the energy. Then you get ADP. It's not really a good source of energy anymore. Remember, it lost phosphate, all that energy. So you can think of it as a dead battery, as you see over there. So the big picture of this is ADP has less energy. ATP has a lot more energy. How we build ATP, I'll let you guys get that link there. Alrighty, well, if we said that we can break ATP, can break that bond to get energy, how do we turn ADP back into ATP? Well, we just use energy, reverse the process, right? Take some energy, put it in there, we get a bond back, and we get our phosphate groups back. Alrighty, and I'll let you guys get this one went there. The ultimate source of energy is going to be sunlight, right? That will produce the most ATP. We especially see this in photosynthesis. Our autotrophs, like take grass, leaves, whatever, that's autotrophs, right? They produce their own energy. Via photosynthesis, I kind of have a little diagram for you here, right? We have the sunlight, the ultimate source of energy, shines on the plant, shines that energy on the plant, right? The plant does photosynthesis thing, right? And it's going to produce a bunch of organic crap we don't really care about right now, but we'll see later. We also get ATP. Alrighty, let's get those. Alrighty, ATP is continuously used during photosynthesis and cell respiration. You know, it's not really going to be a long-lasting one. If you look at our energy molecules, right, we saw glucose, we use that for energy, it's a carbohydrate, we use carbs for energy. We also have ATP. What's the difference here, right? ATP is going to be used quickly or it's going to degrade, right? But glucose, remember, we can turn that into polysaccharides, store it for later, right? So just to recap here, right, we're going to look at breaking ATP, and then we'll also look at reversing it. So with our ATP adenosine triphosphate, we're going to break that third bond, right? It's going to release energy, and we're going to get ADP, adenosine diphosphate. Remember, if we're releasing the energy, we're going from a full battery to a dead battery. And if we were to reverse it, right, we go to ADP to ATP. We're going to use energy to form that bond back, and we're going to get that full battery again. And that's all the notes for you guys.